So today we are going to discuss on part 4.3 of arrays, arrays utility class, sorting, searching, arrays utility class, and an enhanced for loop. So Java provides a utility class called arrays in the java.util package. This class contains static helper methods that perform common operations on arrays. Unlike classes such as string or integer, the arrays class is not part of java.lang, it's part of java.util, and so it must be imported explicitly before use. For OCA exam, there are 5 so this we must remember, right, that arrays is not part of java.lang, so it has to be imported explicitly before using it. For the OCA exam, there are 5 important methods to remember, right, from this. The first is sort, which arranges the elements of an array in an ascending order. Second is binary search, used to locate an element within a sorted array. Third is toString, which converts an array into a readable string format. And fourth is equals, which compares two arrays element by element. And finally, there is a range version of sort, which allows sorting only a portion of an array, which allows sorting only a portion of the array, right, not the full array. You can sort a particular range of the array also. So understanding these methods is very important. So let's look at each one in more detail. Sorting the array, right, Arrays.sort. The method Arrays.sort with a single argument sorts the entire array in ascending order. The sorting is done in place. Sorting is done in place, meaning the original array itself is modified, right? So method does not return a new array, so there is no return value to store. Java also provides 2 argument version that allows you to sort only a specific range of the array. For example, say you sort Arrays.sort ARR, then 1, then 4. It will sort the elements at indices 1, 2 and 3. Not the 0, not the 4, right? It will sort the elements at indices 1, 2 and 3. The second argument represents the exclusive upper bound, so index 4 is not included. This follows the same rule used by methods such as string, the dot sub string, where starting index is inclusive and ending index is exclusive. Any element outside the specified range remain unchanged. For example, if an array contains values where index 0 is equal to 5, 0 is 5, and the last elements are 9 and 2, those values stay in their original position. Only the elements within the specified range are sorted. For instance, if the middle portion of the array contains 381, and after sorting this section it becomes 138, well, the rest of the array will remain the same. Okay, that we have shown here at in the last example of this page. Printing arrays. How do you print toString versus direct print? So if you print an array directly using system.out.println, the output is not very useful. Instead of showing the elements, Java will print something like @1b6d35 etc., which represents the array's type descriptor and hash code in memory. To display the actual contents of an array, you should use Arrays.toString bracket. So this method converts the array into a readable string format such as 1, 2, 3, making it much easier to see the values stored in the array. However, this method works properly only for one-dimensional arrays. For two-dimensional arrays, Arrays.toString will display the inner arrays as reference values, not their contents. In such cases, you should use Arrays.deepString, which processes the array recursively and then prints all nested elements correctly. In the exam questions, you may see code that prints an array directly with system.out.println. The expected output will be a reference string hash value rather than the actual array elements. Okay, you have to remember that. Next is Arrays.binarySearch, right, the contract that you must know. Binary search is a very efficient search algorithm, but it works correctly only on a sorted array. So you have to remember that the array must be sorted. So the most important rule to remember is that sort the array first, then only perform the search. If the array is not sorted, the result of the search is unpredictable. When the target element is found, the binary search method simply returns the index of that element in the array. If the element is not found, the method returns a negative value. The return value follows the formula minus then within bracket insertion point, then minus 1. You have to remember that, right? See, if the element is not found, the method returns a negative value. The returned value follows this formula: minus within bracket insertion point, then minus 1. The insertion point is the index where the element would be inserted to keep the array in sorted order. For example, consider the array 1, 2, 3, 5, 8, 9, right? If you search for the value 4, it is not present in the array. To keep the array sorted, 4 will be inserted at the index between 3 and 5. So applying this formula gives, what does it give? Minus 3, then minus 1 is equal to minus 4. Therefore, the method returns minus 4. In exam questions, you are often given a sorted array and a search value and asked to determine the result returned by the binary search using this rule. Array.equals versus equals. So array equality follows a pattern that is similar to string comparison. The operator equals compares references, not the actual contents. This means that if you create two separate array objects with identical values, they are still different objects in memory. So equals returns false. To compare the contents of arrays, you should use Arrays.equals. Arrays.equals. To compare the contents of arrays, you should use Arrays.equals. This method, it checks the arrays element by element and returns true if all corresponding elements match. There is an important detail when working with multi-dimensional arrays. So if you use Arrays.equals on a 2D array, right, it compares only the first level of the array, which means it compares references of the row arrays. Since each row in a 2D array is itself a separate array object, so 2D arrays with identical values will usually return false when compared with Arrays.equals. To compare all elements recursively in a multi-dimensional array, you should use Arrays.deepEquals. We discussed this. In exam questions, you may see two 2D arrays with identical values compared with Arrays.equals. The result will typically be false unless both variable reference the exact same inner rows in memory. Enhanced for loop, syntax, capabilities and limits. The enhanced for loop, also known as the for each loop, provides a simple and clean way to iterate through an array when you only need to read its values, right? The syntax looks like this: for int element colon ARR, which means for each element in the array ARR, assign it to the variable element. A key limitation of the enhanced for loop is that you cannot modify the array elements through the loop variable. Each time the loop runs, Java assigns the array value to the loop variable as a copy. So if you change the loop variable, for example, element is equal to element into 2, you are only modifying the local copy, not the actual value stored in the array. So as a result, the original array remains unchanged. So exam questions often show an enhanced for loop where the loop variable is modified and then ask what the array contained afterward. The correct answer is that the array values remain the same, not changed. Okay. If you need to modify array elements, you must use a traditional for loop with an index such as array I equal to whatever, right? So another limitation is that the enhanced for loop does not provide an index. Because of this, you cannot easily skip elements based on position, iterate in reverse order, or access neighboring elements. These are very important points to remember for the exam, right? So in which conditions you will require a traditional for loop and in which condition you will use an enhanced for loop, right? So because you cannot easily skip elements based on position, iterate over reverse order, or access neighboring elements. For these situations, a traditional for loop is much better choice. Break and continue in array loops, right? So the break and continue statements behave the same way in an enhanced for loop as they do in a traditional for loop. The break statement immediately terminates the entire loop. Once a break is executed, the loop stops and no further iterations occur. The continue statement works differently. It skips the current iteration and moves directly to the next element in the loop. For example, in a loop iterating over numbers, if break is used when n equals 3, then the loop stops at that point. However, as a result, only 1 and 2 are printed and the remaining elements are never processed. In contrast, if continue is used when n is equals 3, that specific iteration is skipped. So the loop then continues to the next value, so the output would include 1, 2, 4 and 5 while 3 is skipped. Let's come to the practice question. So we have int array and then 42715 arrays.sort, so it gets sorted. So it becomes 1, 2, 4, 5, 7. Then system.out println Arrays.binarySearch arrays 7, which would be 4, and system.println Arrays.binarySearch arrays 6. Now in case of 6, you see 6 is not found, right? If the key is not present, then it will return what? Minus insertion point minus 1. 6 should be inserted at index 4, right, between 5 and 7. So result is minus 4 minus 1 is equal to minus 5. So enhanced for n plus 10, right, for this. But this changes affect only the local variable n, not the array. So that array will remain unchanged. You are changing a lot within the array, but it will not change anything with the original array, right? So that array will remain unchanged. 1, 2, 4, 5, 7. So what will be the total answer? Answer is B, 4 minus 5, and then the array 1, 2, 4, 5, 7. Okay. So if you want to practice more questions on this and see detailed explanations given, we have 29 full-length practice tests and 1624 practice questions, all timed simulating real certification tests at javalearn.clustermicro.com. You can enroll yourself there and practice happily. Thanks for your time.